Okay, so this is the interesting part, right? So your question is, well, how does, what does Apple recommend doing to target all these devices? What they recommend doing is they recommend creating a group of files, and this is TN2224. Who here has heard of TN2224? This is like a seminal document. This is like the tablets from the mount. This is probably the most important document Apple ever put out as it relates to targeting their iDevices. And what they recommend is producing, again, we're talking about adaptive streaming, one file in, multiple files out. They recommend encoding using the baseline profile for low-end, mostly cellular devices, main profile here, and then high profile for the 1080p iteration. And basically, they do that to match up with these groups here. Okay, so this is the schema that Apple recommends. Now, if you wanted to produce one set of streams and deliver them to both computers and mobile devices, what questions would this raise in your mind? And your concern there, so do we adhere to the lowest common denominator? And the obvious driver for that is how much quality difference is there between files encoded using the baseline profile, files encoded using the main profile, versus files encoded using the high profile all the way through. So to kind of summarize that, if there's very little difference in quality between these files and these files, then you probably would create one group of files. It's, you're encoding 1/3 the files and distribute them everywhere because there's not much quality difference. On the other hand, if there's a huge quality difference between these files and these files, then you might consider encoding different groups for different targets. You're tripling your encoding expenses, you're tripling your storage expenses, you're cutting your cacheability of your content by 1/3 or 2/3, and so you're doing a lot more work. So the big question that relates to all this stuff that we're talking about is how much difference is there, and I'm sorry for going back and forth, between this and this. And that's all these intermediate slides kind of say. So here's another application of the video quality measurement tool, and I just wanted to see, how much difference is there in the files. And then this is the cute picture of the tool again. So what I did here, and this is a test file with significant scene variability. This is not your talking head. This is very low motion at the start, very high motion at the end. Encode in these parameters, which are directly off the TN224 recommendations. So these are all baseline. And these are all main, and this is high here. And then I measured the VQM using the Moscow tool that we looked at a few minutes ago. And what I saw was, at the 480 by 270 configuration, there's an 11% difference in quality. At 640 by 360, 600, there's a 29% difference in quality. At 640 by 360, 1200, there's a 10% difference. And these are all baseline, right? When you get to the main profile versus high, I saw very little difference at all. So this is one set of tests. And this is I guess this is probably the 640 by 360 at 600. And this is the largest visual difference that I saw. And again, you can download the handouts. It's going to be much clearer on the PDF. It's probably not so clear up here. Certainly not clear on the printed handout. But you'll notice that there is some detail loss here versus here. And the face of the forklift driver is a lot worse off here than it is here. So there are noticeable differences in quality. On the other hand, this is our talking head video. This is a political speech from the last congressional election, not this year, 2 years ago. And it's just the candidate speaking for 60 seconds. No motion, no graphics, no nothing. And here we see almost no difference in quality between the baseline and the high. So if you're producing a news spot and it's or a commentary, there's not a lot of dynamics. You're not cutting to a football game on Friday nights. If there's very little scene variability, you're not going to get a lot of difference between the baseline profile here and the high profile here. On the other hand, if you're shooting sports, if you're shooting high motion, if there's a lot of variability in your scenes, you will see a lot of difference. So this is the difference between the high and baseline profile in a file with a lot of motion and scene variability, and we see big gaps here. This gap tells me, man, there's a big difference in quality here, big difference here, big difference here, and this is what it looks like with the low motion sequence. There's almost no difference between the quality. Everybody get this? Pretty cool tool. I think it's the only tool I actually bought. It's called the Moscow State University Video Quality Measurement Tool. And I had a consulting contract this summer where I was evaluating HEVC technologies, and I had like 240 files to compare. And the way I started out thinking I was going to do it was to eyeball them. And I ended up buying the tool because it just saved so much time. And the thing is, it really makes you look, I bought it because it saved a bunch of time. And really what it did is made me look like brilliant, right? It's like, we're not talking subjective differences here. These are objective numbers, PSNR, VQ. So it's really, if you want to really objectify the small differences that sometimes exist between the different compression algorithms, encoding tools, blah, 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 it's a great tool. I should also say there's a version of it that's free for under 720p. So if you're comparing files in the 640 by 360, you can use the free tool. And that's almost a no-brainer to pick up and compare. Okay, so again, the problem we're addressing here is, do you produce multiple sets of adaptive streams depending on target? And some using baseline for compatibility with Android, some using high profile for compatibility and quality with computers and OTT boxes. Most of the big sites that I've worked with tend to customize. They produce different streams for different targets. Most of the smaller sites tend to use one set of streams and then they transmux. Okay, by transmuxing, they change the container format for different targets. And as we saw, the decision, I think, is content dependent. If you've got a lot of variability in the scene, you're going to see a big difference. If it's a very low motion scene, you're going to see a small difference. What I found interesting was main was very close to high, even with a variable file. So we saw a huge difference here, but almost no difference here. So I'm not sure there's ever a reason to encode separate streams just to make the one set of streams high profile as compared to main profile. This is kind of logic. My application of logic. My bent is do one group of files and transmux. Again, that different strokes for different folks. I look at this and I say, okay, the average broadband connection speed of computers, average broadband connection speed is around 10 megabits per second. So while I'm producing this stream at 640 by 360 for mobile customers, how many actual computer users are going to view this screen? I mean, how many computer users are actually going to view a 600 kilobits per second stream as opposed to bouncing up to the 1200, 1800, 2500? So it's not just the quality is different, it's how many people are actually going to see it. On the mobile side, there's probably a lot. On the computer side, I think it's a pretty small number because they're all on cable modems or internal networks, and they're all streaming at much higher, or downloading at much higher rates. So I think relatively few users would see this stream. There's not that much difference in this streams, but I think you really can justify saying, okay, let's just do baseline. On the other hand, if the client says we want absolutely best quality for everything, and the scene changes, if it's got high variances of motion in the content, then I think you really need to consider separate streams for the separate targets. And then I worked with a client this summer where they had to create separate groups of adaptive streams for DRM purposes. So they were using the Widevine DRM. They had to create one group for HLS, one group for computers. And then it's like, okay, if you're doing the separate groups anyway, do the computer one's high profile, do the iOS one's baseline profile. If you have to do it anyway, optimize the profile. Okay, a couple of things. We covered profiles. This is levels. What do levels do? Levels constrain key parameters within the bit stream. That's really a problem if you're dealing with mobile devices. And so if we look back here, we see that each mobile device that Apple releases has a different level not to exceed. If you exceed that level, the video file won't play. If you meet these parameters, you won't exceed the levels. So TN2224 will avoid any problems with Apple devices. And sorry for jumping back and forth. So critical not to exceed the level of the target device. It's only going to be a problem with mobile. It's not going to be a problem with desktops. Desktops can play H.264 encoded video, any profile, any level. So, and really, if you stick to the TN224 recommendations, you're not going to run into any level problems. Just wanted you guys to know what they are.